from the river and then use it, and then the rest of water they discharge into the river, back to the river. Okay, so for the big city, what do you think? What are the factors that will impact the demand for the big city? Anyone can tell me?
Population, sir.
Yes, so the population. The first thing is population. What is next? Another factor. Do you guys remember that we talk about this thing? What are the other factors that will control your demand? Water use rate, yes. Water use rate mean per capita water use. And then how are the agriculture sector? In the agriculture sector, what factors are important? Yes, so agriculture sector, land area is important. What else? It is important in agriculture sector. The other factor that is important is that what kind of crop you will cultivate in the region and what is the timing of your cultivation, right? So maybe you can start cultivation of crop maybe mid-June, and then July, August, September, October until November, 5, 6 months you need water, and the rest of the months you don't need the water. So the irrigation scheduling is also really important for this agriculture sector. Okay, so let's everyone go back to the data section and we will check that what things we have right now. So key assumptions. Last time we created key assumptions. Key assumption mean unit domestic water use. So how much water per person we need. Then unit irrigation water need and domestic variation. So can you please check these three key assumptions are there in your WEAP? Then let's open up this demand sides. Demand side stands for that how many sectors need water. In this particular case, big city, which is actually a domestic water side, and then the agriculture. The third part is hydrology. So in this particular scenario, we did not provide any data except the stream flow in the river. The hydrology section we will discuss later on. And then supply and resources. Supply mean it can be river, it can be a groundwater resource, it can be a water tank, it can be any kind of source that supply water to these demand sites. All right. So whenever you want to check what is the demand sites, just click here. These are demand sites. And then the supply and resources. River is one of the thing that supply the water, and the transmission links, for example, like the pipes, all of the stuff, they are considered as transmission links, and the return flow. Again, these are also transmission links that bring water from your domestic site back to the river. Okay, you can check one by one by clicking big city. If you click the big city, you can see that the growth rate, they have added the growth rate of 1.5% in here, and I don't know, the population in 1990, they provided then annual water use rate, monthly variation, and consumption. In case of agriculture sector, they have provided the annual activity level, which is 100,000 hectare of land that is cultivated, annual water use rate that is provided with the help of key assumption, unit irrigation water need, monthly variation. So you can see that in the month of January, February, and March, we don't need water. We need water in April, May, June, July, August, September, and October. Even in October, we don't need water, it's zero. Okay. Now, in this particular session, we will try to make different scenarios. I remember last time we tried to make different scenarios. Okay, so let's say we need to change for this exercise, go to general, times years and time step. And can you change the last year to 2015? Again, the current year will be 2000 and the last year will be 2015. And close. Okay. Now, can you please create a key assumption with the name population growth rate of 2.2%? Can you create a key assumption? Create a key assumption with name population growth rate, and the population growth rate value should be equals to 2.2%. Can you guys do it by yourself? And please let me know once you are done with this key assumption. Luis, can you create the key assumption? Luis. Jefferson, how about you? Are you done? Okay. And how about you, Kyle? Are you done creating the key assumption? Henry, why your camera is off? Henry and Alyssa, your cameras are off.
Hello, sir. I think there's something wrong with my camera, sir. It's not working.
All right, so still turning on. Okay. So Alyssa, did you create this key assumption?
I just came in, sir.
All right, okay. Can you do it very quickly? So I can
I
put.
also can't do it, sir, because I'm using my phone right now. My laptop is with my younger brother. He's using it right now. It's the only laptop we have currently.
All right, very good. So how you will learn the VEEP if you don't have the VEEP in your computer now? Can you
We
note
just.
down the steps?
Yes, sir. I'm taking screenshots, sir.
Okay, good. All right, students. So whenever you want to create a key assumption. So go to key assumptions section and click right and click on the add. And let's say I create a key assumption with name population growth rate. Sorry. Okay, I have created a key assumption with name population growth rate. So if you click in here, sorry, so there is a unit over there. So you can just click it, no unit. You don't need to have any unit. Wait, no unit. It is a percentage, right? You can also change it to unit to the percentage. There is a percentage as well. I don't know where is the undefined. Share people no data. We don't need yet. Just do the percentage. That this is a percentage. We know that this is a percentage, and just put the 2.2 here. Our next step is that we have to create a scenario now. We go to scenario, sorry, the data in here, manage scenario, and click here. So right now you can see that you have a current account. I mean, the current account means your base year. So all the data you input is for year 2000, and you are trying to estimate for next 15 years, starting from 2001 until 2015. Okay, now this is a scenario in which the population growth rate was 1.75%. Now I want to add another scenario and I want to compare if the population growth rate is 1.7% and if the population growth rate is 2.2%, how different is water demand and supply kind of things, and what are their dynamics? Okay, so let's let's add another scenario in here. So maybe let me add that what kind of what is, should be the name here. So before we further go here, uh, okay, so for now, just close this one. We already checked this one. And then describing the reference scenario, we change the unit irrigation water use rate. Okay, so go to unit water irrigation rate, click reference scenario, and in reference scenario, click yearly time series. So in this case, what we're gonna do that we are not only changing the population growth, but also we want to change the what they call it, the agriculture land yearly. So maybe the government, they made the policy in the region and they are giving extra land to the farmer. So with every year, we will add new agriculture land in our city. So let's click here, yearly time series. So if you click on yearly time series, there are for several options: linear interpolation, step function, maybe smoothing curve, linear forecasting, exponential for function, and the logistical thing, right? So let's click on the linear one and click next. And then it will ask you that you want to enter the data. You will say that, yeah, I want to enter the data. And then click next. And you have to add the data. So for year 2000, maybe in 2005, let's say 2005, the agriculture land will decline maybe 3300. Then add another year, 2010. Maybe there is urbanization in the region and there is agriculture land is decreasing. And then 2015, we will have 3150. All right. So growth last year, you don't need to finish. All right. Can you do that? Please let me know once you're done. And then maybe population growth rate. Let's say uh, for the current period, it was maybe 1.75. And for the reference period, it is 2.2%. Can you do that, please? Now we did two things. First, Junot irrigation water needs, it is decreasing, and the population growth rate, it was earlier 1.75, now it is 2.2%. So please let me know once you are done. Are you guys done? Okay, so let's go to the scenario section now and click on the reference. And under the reference, add another scenario with name high population growth. And press OK. So under the scenario reference, it is high population. So students, here one thing is interesting to note. If this high population growth is under the reference, so it means all the data it will take from reference. So for example, I can change this one. It can be under a current. Did you see the difference? High population growth. So it means this high population growth, it will take all the data from current account scenario. But if I do this one, it means the high population growth will take all the data from the reference one. Okay. Now, have you created this high population growth scenario? All right, and then close it and press OK. Now, just for the double check, just double check that how you are putting the this scenario. So go to the big city, and then in current account, let's say in the sorry current account, the population growth rate is 1.75%, right? For the reference, the growth rate is again 1.75%, right? And then for this one, high population, it is also 1.7%. So what we can do is that we can change it to maybe 2.2. The only difference for this reference, for the reference, it is 1.75%. For this high population, it is 2.2%. Have you tried this one already? Are you done? Okay. So students, sometimes you will ask the question why we need key assumption. For the key assumption, what I can do is that I can change I can link this 2.2 value, 2.2 value to my population growth rate. I can change it, right? So for example, I can link it to, for example, let's say, I would say, go to look up expression builder, and this 2.2%, I will just delete this one and go to the branches, drag, and down where is my population growth rate. I will just put it in here. Verify, OK, and finish. Now, one thing what we did in here is that in the population growth rate, I guess, we added a percent. Let's not add anything. And then go to, oh, it's too much. The population is increasing too much. Annual water level. I think that we need to change it. Just give me a 1.75. Reference is 1.75. High population trade builder. Maybe we need a percentage sign. Okay. Okay, so the percentage sign was missing. So can you double check? Go to the current, check the value should be like this one. If you go to the reference, the population is 1.75. For the high population, it should be like this one. Can you please double check? We're done. Mr. Kurt, are you done? Making these three scenarios? All right. So if you are done, this one, let's try to compare our result. So go to the results section and it will ask you, your results are out of date. You want to recalculate? You say yes. Just recalculate. Okay. And now from here, go to water demand and then let's compare our annual demand. This is our big city. Yeah. So high population growth rate and reference. So in here, you can see that when the population growth rate in the reference scenario, it was 1.75. The water demand increases this way. I increase the population growth rate to 2.2%. This is my result. Now, if I go back to my data section and where is my population growth rate, I will increase this one, just give me, to maybe 5%. Let's say I increase it to 5%. And then I will check the results again. Do you see a difference? There's a huge difference now when the high population growth rate and for example, this with 1.75% growth rate. Vince, Vince, can you tell me that your results look like same? All right. Juliana, how about you? The results are same? All right, good. And How about Joshua? Neil Joshua? Your results are the same? Okay, so for example, now I ask you to add another scenario in which I would say that uh, maybe the add the what they call it, the agriculture scenario. Can you add the agriculture scenario as well? So add another scenario with declining of agriculture land. So for example, if you see here, if you go with the agriculture sector, it look like same. In both scenario, there is no difference. But if you want to add, go to data in the agriculture sector, and then annual water use rate, and for high population reference. Oh, it's already added over here. Okay, so I think we should not add this one in our this scenario. Okay, so it's already added. It's already added. I can see now. Yes. So high one need this one. Key assumption, and then key assumption. All right, so it is already added over there. So now we can also add unit irrigation water needs, domestic variation, domestic water use rate, and population growth rate. For example, if you change the unit domestic water demand, for example, in high population growth rate, you say that maybe in future, in high population growth rate, we need 400 cubic meter of water. And then go results and check. There will be a huge gap. And then this will be, if you want to check the unmet water demand, maybe this is your unmet water demand. Okay, our next target is that we already told we already create a scenario in which we have added a change in your agriculture and the big city, your demands. Do you think the flow in the river for every year it will be same? Do you think? But once we add the data, let's say we add the data and in the river section, the flow every year it is same. Can you check? Go to your data section and the river. You will see that your data, the amount of water every year it is same. Do you think it will happen in real life that the flow every year will be same? Right? It will never happen. So now what we can do that we can say that, let's say in the year 2000 there was a supply of water, but let's say in year 2001 it was a wet season, then there is a drought season, a dry season, three consecutive dry seasons, then we have wet season again, which is flooding season, then we have three consecutive dry season, right? Let's try to make that kind of scenario that although our maybe our population is also increasing, domestic water demand is also increasing, agriculture land is declining, and maybe we can also add the dynamics of water supply, the water that can be delivered to these areas. So now we can make a scenario in which the available water in the river, it will change. Okay. Now, now we have to create a water year. So the water year method is simple. It is a representation of your climate change. So such as the stream flow, maybe, of course, when there is a less rain, there will be less amount of water in your stream, in your river, right? So in this one, we will first define how different climate regimes, maybe very dry season, then wet season, and very wet season. Okay, so let's go to your data section. In data section, you will see under the hydrology water year method. Can you see? Now just click over there. So over there, you will find there are various terminologies, very dry, one, everything is one. So let's try to define our scenarios here. So what do you think when there will be a dry and when it will represent wet season? Do you have an idea? So for example, one mean the average flow is same throughout the year. If you put a value of 0.75, it means the stream flow is reduced 25%. Okay, so let me define very dry mean if 0.70. It means my water in the stream flow is reduced to 30%. And let's say I define a dry season 0.8. It means the amount of water it is reduced to 20%. And wet season, let's say in wet season, the amount of water in your river, it will increase. So let's say the 30% increase of your water. And then very wet season, it means 1.45. It means your stream flow is increased 45% to the normal. Okay. So I forgot to tell you that it should be your reference. Okay. It should be, please check over there. It should be your reference, because if you put high population, it will just show in high population. But if you change this one into the reference scenario, it will add all the scenarios under the reference. So you can just change it again, 0.7, 0.8, sorry, 0.80, 1, enter 1.20, 1, sorry, 1.45, so 30. All right, so can you please make this 4 different types? And then go to the current, and it should be normal, okay? Now you have to define which year is normal and which year is not normal. Can you do that? Can you see these things in your Uh, sorry. Oops. Okay. So let's say we can say that from year 2001 to 2003, 2001, 2002, and 2003, they are normal seasons. In 2004, let's say that season was very dry. Click on very dry season. Then in 2005, let's say it is very maybe wet season. Then let's say 2006 and 2007, 2008, they are normal seasons, and 2009 and 2010, they are very dry seasons. Then 2011, it was a very wet season. It meant flooding. In 2012, let's say it was normal. In 2013, let's say it is wet season. And in 2015, it is 14 normal. And 2015, let's say it is a dry season. So here is the definition. Here is the sequence. This was your definition. And this one is your sequence of the years. So it means in 2004, you have less amount of water compared to the normal season. But in 2005, you have more water compared to the normal days. Once you are done with this one, you can simply run. Maybe you can check your rivers. Maybe mean river. It should. Just give me a minute. Rivers. Okay, we did not add this one. Okay, we need to add. So are you guys done with this, adding this one? Sequences? Are you guys done? Okay, so you have defined that these are my definitions for dry, wet, and very wet. These are my definitions. And then I have added the sequences. Again, okay, yeah, same. Now you have to go back to your river. And instead of here, I think you have to go to first reference, and then click on water year method. So now you can see that the stream flow is not constant. It keeps changing. So first 4 years, they were normal seasons. You can check water year method. Sorry. First 4 years, first, second, third, fourth. These 4 years, they were normal season. So normal season mean that the flow in this river, it will be unchanged. But the next year, 2004, it was a dry season. So dry season mean the stream flow will reduce. Then in the very next year, 2005, it was a wet, then the normal to dry, then very wet, then normal, then wet, then normal, and then dry. All right, students. So now you can check your answers results. Now, did you see? This is unmet water demand. Now, the unmet water demand is not constant. It is keep changing up and down. In year 2004, it was a dry season. Unmet water demand is suddenly increased. Year 2005, it was a wet season. So wet season means more water available. So unmet water demand suddenly decreased. First 4 years, it is same for individual scenario. And the last year, it was a dry season. So suddenly your unmet water demand increased. Catherine, are you tired? It makes sense to you? Are you still trying to understand? Okay, good. Rika, how about you? It makes sense? Perfect. How about you, Meg Austin? How about you? Meg, I cannot see you. Calienta, how about you? Is it clear?
Yes, sir. Just a little bit tired.
Okay, so I will not give much pressure for today. Just go slow. And if you have a question, just ask me. Okay? And maybe my Ira, you're not here today? Ira is not here. Okay. Azra, you're here, right?
Yes, sir.
Azra, where is Ira? She's not in the class today.
I don't know, sir.
All right. And I think, okay, both of only you are available for this group. Anyways, so Ezra, do you have any question? And for this particular topic, I mean, creating the scenario, because you will be the one creating the scenario in your project.
None so far, sir.
All right. So, students, one more thing I want to add right now. What we did, I will just summarize. We did that we have a city and an agriculture land. In city, the population is growing. For the agriculture, in future period, maybe there is we are decreasing the agriculture land because there is urbanization. We create new cities in the region. We develop new cities, right? So also the factor of climate change. The factor of climate change will impact the stream flow in your river. You will not expect that the same stream flow every year or every month. There will be a change in your stream flow. So considering that particular observation that we added these water year methods, we can check that when the stream flow will be higher, then what should be our policy? When the stream flow in the river it is less, what should be our policy? And once you see the results in here, you can see that all those years in which there is a dry season, suddenly unmet water demand increased. Unmet water demand in 2009 and 10 increased because these were your dry seasons. All right. So in year 2011, Did you notice in year 2011, there is no unmet water demand in 2011 for reference scenario. Why? Because once you check the data in 2011, suddenly the stream flow is increased. All right. So what else we can do here? Ah, now, what we can do here as well, we can compare that, let's say, for the, sorry, river, for this reference scenario, let's say we have this data, but for the maybe the high population growth, we will say that use water year method. For reference, now your result will again be a little bit different. Did you notice the scenario in which we did not add the climate change factor? You can see that for the reference scenario, the unmet water demand is constant. But once we added the impact of climate change, you can see the spikes. The unmet water demand go up and down under the scenario high population. Similarly, you can make several scenarios in here. You can make the combination by going here. You can make another scenario. Let's say you say that I want a high population growth rate. Add another one, maybe climate impact. Right? I want to see the climate impact. And I will just close it. And let's say the factor in climate impact, I want to maybe change the definitions of water year. So maybe I can just go in a water year, and then I can change the sequence. And maybe under this one, I would say that my years are very dry. Most of my years are very dry. And then I will say, okay, now I want to check. Now you can compare two different years when I change suddenly 2011. You can see a difference, high population and the climate change impact. I just changed here year 2011, very dry season. But in year high population growth, 2011 was very wet. Once I see the results in 2001, you can see that when it is very dry, the unmet water demand suddenly increased. And when it is a very wet season, unmet water demand is less. Now, what happens in real life? In real life, what happens? This stream flow data, we try to simulate. We do hydrologic modeling. You guys know what is hydrologic modeling, right? So what you do, you use a third-party software, for example, HackHMS, or you use another hydrologic framework like Raven. One of my group, they are using Raven hydrologic model. All right. So instead of using these values, you try to link your streamflow data from a third-party software. You can couple your WEAP model with a hydrologic model. By default, there is a way that you can do a hydrologic modeling in WEAP, but I think we should not do that in this course because it's more about the hydrology kind of stuff. But maybe in our next class, I will give you an idea how you can do the hydrologic modeling in WEAP in our next class. Okay. So now, if you have any question regarding the supply, demand, um, any climate change or stream flow, or any question regarding this one, please let me know. Okay, so if you don't have any question, let's have 10-minute break. And after 10-minute break, we will try to uh, aggregate more stuff like household use and add more refined things in our WEAP model. All right, so maybe we can have 10 to 15 minutes break. All right, student. So sometimes what happen, we have to do a demand and supply analysis on a micro level. So macro level mean that we are talking about maybe the agriculture land, the maybe industrial land, industrial areas like this thing. But sometimes we have to do some micro level. For example, we will go deeper into the household planning. So, for example, how many people are living in a particular house or apartment, the family size, the what kind of washing machines they are using for cleaning, all other stuff, right? So let's try to do this thing in VIP. So for this particular tutorial, you have to go to the revert session, and then you can do starting point for, wait, you have to click on answer key. Just give me a minute. Demand analysis, supply analysis is not scenario module, starting point. Wait, let me tell you. Starting point. Scenario module. Starting point. Okay, so you have to go starting point for the most modules after scenarios module. Can you click here? Click here and press yes. Now what you have to do that, go to in this particular page, you have to create a new demand site. So let's create a new demand site by click and drop it somewhere. Maybe you can just drop it somewhere here and give it a name rural and activate in the current account, yes, and demand priority 1 and then finish it. And then please add a transmission link from this river to your rural, and then the return flow from this rural to this place. Can you do that? Now you have added another demand site here. Please let me know once you are done. Okay, James done. Anthony, are you done? Dominic is done. Juliana, how about you? Alan? Okay. Alan is done. Nadine, how about you? Are you done? Okay.
Yes.
Joy. All right, it's done. Ira, how about you? Done?
Yes, sir.
All right, so now you have added another demand site. The name is rural. And you have connected this rural demand site to the river, and there is a return flow as well. And now you have to go back quickly to the data section. Once you see the data section under the demand side, there is another demand side with the name rural is added. All right. So in the rural, let's say there are two type of housing. One is apartment building and one is single family houses. All right, so can you please click in here and add under the rural section, let's say single family houses, and add another with the name apartment buildings. So under the rule, right click, add, and add these two single family houses and the apartment buildings. Are you guys done? Again, under the rule, single family houses and the apartment buildings. And under, again, single family houses, let's add the sources, the demand sites again. So add in a single family houses, what do you think? What are the demand resources? Maybe you can say shower, the restroom, right? For shower, you can use the water. And what else? Maybe you can have toilets. What else? Washing. And cooking, maybe just add other. Can you add these 4 things: shower, toilet, washing, and others in a single family house? Don't add data yet, okay? Just make the structure. Okay, if you're done, let's go to the rural section. And in the rural section, can you just put under the rural, add the household? Click on the household and press OK. Let's say there are okay. Let's say there are 120,000 households living in this particular rural section. And for the single family, let me just, okay. Let's say share 70% of the share is 70% of the share is for the single family houses, and 30% is for the apartment buildings. Can you add in this way? So let's say we are saying that 70% of the people from 120K people, 70% have single family houses, and the 30% they are living in the apartment. So in here, you can also use the expression builder by just saying that there is a function named remainder, I'm gonna pick you up. Remainder. Just click on the remainder. Sorry. And remainder of what? So go to the branch and maybe single family houses. Annual activity level. Sorry. So if it is 70, it will automatically be 30. Percent share. Maybe just put, I don't know. Maybe you can just put 30 for now. Yeah, 30 for now is okay. Just keep it 30. 70 and 30% share. I don't know why it is not working, but anyways, just put like 30 for now. Okay, you guys are done? So we were adding a rural area in which 70% of the people of the houses, they are single family houses, and the 30% are the apartment buildings. And under the section, you will see that the single family houses, there are shower, toilets, washing, and others. So let's say that among 70% of the houses, 80% of the people, they have showers in their houses. Let's say 80%. So you have to add the word saturation, and then you say that 80%. Oops. I don't know why sometimes it happens in my rural and single family houses. Then just add saturation. Okay, saturation. $80, and then toilets 90, washing machine 55, and 35%. Okay, so let me explain. So there were 120K people, households, and 70% of the household, they are single family houses. In 70% of the single family houses, 80% of the houses, they have showers, 90% have toilets, 55% they have a washing machine for the washing the clothes, and the other stuff like 35, the cooking and all other stuff, 35% of people they have these things. Now, one thing you have to notice is that what is the difference between shear and the saturation? Can you tell me what is the difference between shear and saturation? Any idea? So whenever you say shear mean the sum of both should be 100%. For example, in the rural 70 plus 30, it should be 100%. But once you go through the saturation in here, so it tells you that among 70% of the household, what is the percentage of the people having toilets? Not everyone have the toilet. So it is saying that 80% of the 90% of people they have toilet facility in their houses. 90%. The 10% they don't have. But it doesn't mean that the sum of the showers, toilet fit, and everything it should be 100%. It's not describing in here. All right. So are you guys done adding all the values? Okay. So our next thing is that we have to add the annual water use rate data now. Annual water use rate. So for the single family houses, let's say the annual water use rate is 80 cubic meter per household. For the toilets, it is 120. For the washing machine, it is 60. And for others, let's keep it 40. And for the apartment building, we will give a value of 220. Can you put the values? So for the apartment, we gave annual water usage 220. And for the single family houses, for shower, toilets, washing machine, and others, we put the values. Monthly variation, I think you don't need to change. And the consumption, can you just change the consumption to 80%? Now, let's check our results. Go to results and click yes. This is our result. So let's try to check water demand among 3 different sectors. So water demand, I want to see all the all the branches. Oops, sorry. I want to see here all branches in here. No, I don't think so it will work. In here, I want to see scenarios. Just give me a minute. Can you check these 2 things for the reference and the high population growth rate, how the things are different? So this one is your monthly based. The previous one is, maybe you can check the annually. This is the monthly. You can see that the rural, how much water demand we have every every month for the big city and for the agriculture sector. Are you guys done with this? Okay. So your results are same. Can you please check? So any question in this part? So I remember last time we discussed this thing, that the the priority. So if you change the priority of this thing, so for example, you want to give the water, the first priority is rural, then you can change the big city, and you can just change their priority by changing the maybe over their consumption. Maybe you can just go data, and for the big city, you just need to change the priority. So if you want to change the priority, let's say your priority is second, you can just put the second in here. For agriculture, if your second priority, and for the rural, if it is, maybe your priority is number one. So you can see the first water will go to the rural section and then the agriculture sector. You can change the priorities in your this, what they call it, the VIP. Any questions, students? Until now? Any other question that comes in your mind? So one last thing I want to add is that at the end, what you can do that you can also export all of your data sets. If you click here, export as CSV file, so you can just give the name to the file. Maybe you can just desktop and then just one and export. So once you open, let me show you, you can export your results in Excel file. Again, if you want to go to export your all the results, you can just export from maybe export to Excel, export to CSV. Also, there is a way that you can export your image as well. Let me tell you from where load a background picture, anime, save file. So if you click save file to the chart, and you can select the maybe the level of details, very high quality, and high compression, low quality, high quality, and then you can just give the path. Sorry. So you can see that this image, it will be generated. So once I give you the assignment or homework, so you can export all of your results, all the figures using this one. And there are other ways like formatting. You can just check the bar charts. Maybe you can, I don't know, whatever you like to do, stacked one, you can add a stacked one. And then you can put the y is equals to 0, 3D. This is 3D. Without 3D, you can use it. Maybe some students, they are seeing like this chart. If you click here 3D, it will show you 3D. And then there's a log. You can add the log chart. Then there are grids as well. You can add the ratio. Maybe you can add the values at the top if you want to add, and print, and then save. All other things, I think you can just explore it later on. So in the results section, if you click on the scenarios, you can compare multiple things. So for example, if you want to see a different chart, so for example, in here it is showing inflow of the area, outflow, and that this is the the supply requirement. This is the unmet water demand. So there are 4 different charts you can add together. If you want to add or remove, just click on the right on that particular, and then maybe you can just move left, right, and you can just click on the remove. If you remove, it will be removed. If you want to add, maybe you can add whatever you want, water demand, unmet water demand. You can add unmet water demand. So you can compare the things. So you know that there is a chart, there is a table as well. You can check the tables, you can check the charts, and in the results section, I don't think so there is other things that we can discuss here. Okay, let me see what things could be good for sure. So I think that's it for this part. Like you can do now simple supply and demand analysis, and I will provide you one homework. Maybe I will upload it, and using the using the VIP model, you can solve that particular numerical. It's just like the EPNet. Okay, I will give you all the data sets, and then you can. And the one thing is that, so for example, if I give you a shape file to add in the VIP, you can add a shape file as well. So for example, let's say that I have a, just give me a minute. So in the VIP Pickle River, okay, let me check. Oh, so this is Pickle River Basin. All right. So let me show you how you can add the shape files. So I will create a new area. Let's say this is your homework. Let's say you save it homework 1. And then you will say that initially it's blank, and you can say that homework 1 of class CE412. You can just give the description. You don't need a password, and copy initially blank, and then press OK. And you say, no, I don't want to save it. Okay, so I'm gonna give you the area that is within the Philippines. So I can just choose in a Philippine area and press OK. And then I will just uncheck everything. And here I can add a vector layer. Right click, add a vector layer. So wherever you will have like the shape file, for example, like maybe numerical methods, second semester. Nope, it was not in here. Okay, so this is the river. So it will open you a shape file. This is the shape file. You can change the shape file like appearance. You want to outline. You want to have like the horizontal. inside. You want to have like the dark fill. You can have like the medium fill. Maybe you want to have the outline color to maybe green. You want maybe, and you don't want to have anything like it's clear. And you can add the widths in here. And what else you can do? Like whatever you want, whatever color you want. And then once you press it OK, so it will be added. So I think this one is added somewhere here. So you can just set area boundary again. You can just select area boundary again and press OK. So this is your, let's say this is your watershed where you're gonna work. And also I will give you the river shapefile as well. Okay, so this one is your river within this shapefile. And then I will provide you the data for the industrial water consumption, domestic water use, and agriculture land in this particular area. I will provide you the stream flow data as well. So you can add the things, and I think it will not be that difficult. Yeah, one thing that I want to add, sometimes you can add the stream flow data. For example, let's say this is my any shapefile, and then you add a river. Let's say my river is starting from here. You have this river. Let's say this is my river. River 1, finish. And let me just check this one. And let's change the size. Okay, level size. Okay, so this is your river. Sometimes what happens, you can add the data for the river. So for example, if you click on read from file, so you can provide the Excel data here. If I provide you Excel data, you can just click here and then open the Excel data, then it will be added. I don't know if I have this one. Let me check. Maybe watershed data. Open. Yeah, this is the stream flow data. Like there are stream flow, precipitation, all other kind of data. You will just select, okay, there is a stream flow data and finish it. So you can check general time steps 2010 2020 close. All right, so in this case, you can add the stream flow data as well. So it's just like you will just click here and read from the file wizard. And then once you click here, you can add the Excel files. All right, and sometimes what happens, we want to delineate our catchment area in our region. Okay, so for example, you guys know how to use QGIS, right? So by default, in Veep, you can use QGIS. So for example, what you're gonna do, you want to download the precipitation and all other data set for this particular watershed. what you're gonna do is that right click and click here, catchment delineation mode. Click here. I will recommend you don't do in your computer for now because it will take longer and you need a very good internet for this one, okay? Because it will download the data. So if don't do for now, just look how you can do that. So you can see that it is my computer is also hanging, even though I have a little bit better internet, but it will make your computer a little bit slow. All right, so I think it is open now. So on the right side, you will get some information. So it will ask you that do you want to download the elevation map, which is digital elevation model. So you can say that yes, you want to add a digital elevation model. You want to create the land cover, land use branches as well. And then it will ask you load climate data. I would say, yeah, I want to use the climate data as well. And then if you select the climate data, there is a free climate data that you can use. So for example, from 1948 to 2014, there is a monthly precipitation data available from the Princeton University. So you can say, okay, I need the air temperature, precipitation, wind speed, relative humidity, minimum, maximum temperature. So download it, you want it. And then you will just, let's say I will click here. Sorry. Okay, and good. So if I click at the outlet point in here, if I double click in here, I will say that my watershed 1 and finish it. Now you see that it delineate your whole watershed starting from here to here. I can drop and drag somewhere here. Oops. There's a way that you can just do it. Just give me a minute. I don't know, sometimes it doesn't work. Let me just delete it again. It should be here. It's still delineating this one. Okay, I got it. So the water flows from here to here, I guess. So we can remove this river, I guess. Okay, so the water is moving from this point to this point. Okay, so this is your flow. So you can just add later on. I will tell you, but it depends on your area to area. So for example, if you want to add an area somewhere in Cebu, you can just select set area boundaries again. Maybe let's remove this one. Okay, it's very simple. This one is simple. Okay. So this is Cebu and this is Lapu-Lapu, and then catchment delineation mode. And if you click somewhere here, Cebu 1 and finish it, you can see that it is, you can see that it added your small catchment here. You can just uncheck all the stuff. So this is your small catchment. You can do the catchment delineation here. All right. So this one will be our exercise in our next class, maybe, but I'm not sure that you guys have a good internet, because it requires a good internet so that it can do everything automatically. All right, students, so let's end class here. And in our next class, we will try to talk about the hydrologic modeling and water quality.